Welcome to video 2 of a 4-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. Today I will be going over how to complete exercise number 2 found in the National Water Model Notebook number 2 titled Mapping and Xarray. First, to access the learning module, or the National Water Model Learning Module, type in your web browser, Hyrolearn.org. This will take you to their main page where you can search National Water Model. Click on the link to gain access. Once you have gained access, it should look something like this. This is the learning module. Here you can learn a lot about what the National Water Model is. A brief introduction is given, a history of the National Water Model, and how it came to be. Section number 2 explains the National Water Model forecasts, such as the short range, medium range, and long range forecasts, and provides a brief learning activity to explore the National Water Model interactive map. This video assumes that you have already gone through and watched and read through all of the content and have a basic understanding for what the National Water Model is. Today we'll be here in the learning activity number 2, accessing the National Water Model through Python code. This is the main page of this learning activity where I'll get you set up with an account in Hydroshare. You should have already done this at the beginning of the learning module, but if you haven't, go back and do so now. The rest of this page will get you set up in Jupyter Hub. Assuming that you have already read through all of this and are ready, I will begin. Here's hydroshare.com or .org, excuse me. We'll come in here and we will begin. Just click on Open With Quasi Jupyter Hub. This will open up the Jupyter Hub notebooks for us. And even if your screen looks a little bit different, maybe a little bit different interface, don't worry, as long as you can see these links to open up the National Water Model Notebook 1, 2, 3, to make sure you open up National Water Model 2 for the purposes of completing this exercise. All right, we'll open it up. And the notebook should look something like this, titled Mapping and Xarray. We'll scroll right down here to the bottom to begin. The purposes of this video are to complete exercise number 2 and provide a basic understanding for what is required. Question 2 states, you may have noticed that each feature or reach in the National Water Model has a variety of metadata attributes, including one called stream order. There are several methods for assigning stream order. You can read about 2 of them at this link. Now try to determine which method the National Water Model uses to order its streams by interacting with the JavaScript mapped above. Is it Strawler or the Shreve method? Perfect. So the first step to completing this exercise is gaining an understanding for what is the Strawler method of ordering streams and what is the Shreve method for ordering streams. Click on this link and we will be given a great explanation for what both stream orderings entail. If you're not feeling confident or you need more information, read through the rest of this. I'm going to provide a quick explanation for what the Strawler method and what the Shreve method means. Alright, so these maps really provide a great overview and a quick way to understand this. Alright, as we can see, we have at the top of these tree charts, ones. 1 stands for the first order of the streaming order. These are smaller streams that lead, and as we know, all streams are going to come and connect into bigger streams and bigger streams and bigger streams until finally they get to really big major streams or rivers where they get let out to the oceans. This is the basic phenomenon throughout the whole world and will always be the case. All right. So as we know, we can come back in just a minute. We'll come back here and we'll be able to open up a map and be able to look at all these streams. These streams, there's 2.7 million reaches throughout the continental United States. All of these reaches come and intersect with each other. Now our goal is to recognize how does the National Water Model order their streams. In the Strawler stream ordering method, we can see that when two ones connect, they add to make a 2. When a 2 and a 1 connect, only the bigger number stays. So in this case, 1, 2, only the 2 stays. And this becomes an order of 2. We can see the same pattern over here. So we have a 1 and a 1. That'll add to make a 2. We have a 1 intersecting a 2, but only the dominant more valued more number will remain. So a 2 will remain here. Same process goes here. Something interesting happens here. Pay attention. So we have a 2 and a 2 intersecting. This will make a 3. So the basic understanding that we need to understand about the Strawler method is that anytime two of the same number intersect, we increase the order of the stream by 1 number. All right, hopefully that makes sense. That's the Strawler stream ordering. Now we're going to come over here to the Shreve stream ordering method. This is a little different. We'll start at 1s again. We have 2 1s, and they add to make a 2. Now we have a 2 and a 1. If it was the Strawler method, it'd be a 2. But we can see here, it's a 3. So what we can see is that when we have 2 numbers, we're going to add it to make a 3. And it continues. There's a 3, a 1 intersecting with a 1, and they will add to make a 4. And the same goes for over here. We have a 1 makes a 2. A 1 and a 2 makes a 3. And we can see down at the bottom, we have a 3 and a 4 river ordering that intersects to make a 7. Okay, so hopefully you can see the difference between the Shreve stream ordering method and the Strawler stream ordering method. All right, using this information, we're going to go back to the code. For the purposes of this exercise, we just need to be able to see the maps that are already coded up in our Python scripts. So we're going to go through this really quick. I advise you to go through this code, read the explanations to gain a basic understanding. For this exercise, we're actually just going to click through it pretty quickly. If you've watched the other exercise or done the other exercises or watched the videos on how to do those exercises, explanation is provided for each of these. All right, so you can simply just click run up here just a bunch of times. It'll run through all the code that's written up. Keeps going. Pretty cool. We generated a map. Keeps going. Keeps going. All right. So cell not executed. So there is one little part that we got to do here. We got to put in a reach ID. It's kind of nuisance that we just have to do. Let me check real quick. Actually, nope. We're good. We don't need to do this part. So once you got this map pulled up, this map is coded with everything that we need. The National Water Model reaches. And as we zoom in the area of the interest in the map, we'll be able to see the different reaches or streams that make up the National Water Model. And then we can get an attribute of the information for the given stream, including its unique ID, by clicking on it. All right, so our whole goal is to identify how the National Water Model, so our map right here, is ordering its streams, whether it's the Strawler or the Shreve. All right, so let's just scroll in here. Let's get to some rivers. There's a river. Bunch of rivers. All right, so the trick to this is finding a good example. Ooh, here's one. Okay, so let's click on this one. And we see down here pops up all the information on it. So it has its object ID or reach ID. It's known by stream ID. Lots of different names for it, but that's there. It's a polyline, of course, station ID. But this is what we want. This is a stream of the order 1. All right, let's click on this one. This is a stream of order 1 as well. All right, so let's click on this one. This is stream of order 2. Now this doesn't tell us a whole lot. If we open this back up, 1, 1 equals 2, 1, 1 is 2, so we don't know which one it is yet. All right, let's go down the stream a little bit more where it connects to the White River. And let's click on right before, let's just make sure it's still order 2. It is. We'll click right here. This is stream of the order 2 as well. And we'll click right here. This is stream of the order 6. This might not be such a good example. Let's find another spot to figure out what ordering system we're using. Maybe we'll come over here. Yeah, let's come right here. This one looks a little bit more. We have a few more streams and rivers intersecting each other, so we'll be able to tell a little better. All right, let's click. Same process. Let's click on this one. We have a stream order 1. Click on this one. Stream of order 1. Let's click on this one. Right where these two rivers are intersecting. Stream order 2. Same thing. That's what we would expect. Now this is going to tell us right now whether it's Shreve or Straller. All right, so we have 1. This is a 2. Click here, and it's a 2. So what does that tell us? We had a 1 and a 1, a 2, and then a 1, and it's a 2 again. So we can see, because of where that 1 was intersecting 2, it's a 2, not a 3 like this one would be. The National Water Model used the Straller stream ordering method. All right, that's it for that exercise. Pretty simple. You can play around, look at more streams. You can even verify what we said. This one right here is stream order 2. This one we already know is stream order 2, so this one should be, click on here, stream order 3. All right, so it is the Straller stream ordering method. All right, that's it for exercise number 2. Hopefully that made sense.